Hey guys, so today we're going to look at Leetcode number 567, permutation and string. So first, when we get a problem, we wanted to look at what kind of category the problem falls into. And here we have a keyword called substring. So whenever we look at the substring, it means that we have a contiguous array of characters. And when we're looking at a contiguous array of anything, we are thinking about a sliding window problem. So now that we know that this is a sliding window problem, let's look at what kind of requirement our sliding window needs to fit into. So we see that here we want our sliding window to contain a permutation of our S1, which is a reference string. So we know that what we need to do is to match every single instance of every single character that appears in S1 with our sliding window that we end up finding. And we need to return true if we can find that window, and return false if we cannot. So let's get into the implementation. So first, I just do a sanity check to see whether the result can ever be valid, and then we start to convert our reference string into single instances of characters that we can actually use to match. So we turn our string into a char array. Note that we are turning it into a primitive type, which cannot be used directly as part of our map. So we have to add the character one by one into our map. So here, here I wanted to also explain a little bit about how I come up with a map as a data structure to keep track of the information in the reference string. So note that we're looking at a permutation, so the characters can be out of order, so the order doesn't really matter. And we also want a fast lookup to check if the character is contained in the reference string. A fast lookup and out of order, so we're looking at set and maps. And initially I made the mistake of looking at sets, and I realized that no, we need to look at map because the set can only tell us if the character is ever contained in the reference string, but it cannot tell us how many times it has appeared. Since we're looking at a permutation, not a combination, we have to match every single instance of the characters that appear in the reference string. So we have to use a map to keep track of the frequency with which each character appears. And now we go into constructing our sliding window, the start index and end index. Match is a variable that tells us how many characters of our reference string we have already matched with our current sliding window. So we use this to check our return condition, or to check our result actually, and we go into the loop of the sliding window. So we're scanning through each character in the second string to match with the characters in the first string. So here, whenever we get a new character, we check whether it is contained in the first string. If it is, then we decrement the number. So the map right now keeps track of the remaining instances of characters that we need to match. So each time when we match one character, we decrement its frequency. And when we find that a frequency has been decremented down to 0, it means that we have matched all the instances of the character, and we can increment our match. It tells us that, oh, we've already taken care of this character, and we can move on to the other ones. So whenever we have match equal to the size of the map, which is the number of unique characters in the reference string, we know that we've matched all the characters and we have to return true. After we check that condition, we need to check whether our current sliding window can still fit into a requirement. What is the requirement here? The requirement is that since we're matching a permutation of the first string, the length of our sliding window has to be the same as has to be the same or smaller than our reference window during our iteration. So eventually it has to be the same size because we have to match every single instance of every single character, and it has to be a contiguous array of characters, so we cannot have any extra character in here, so we need the length to match exactly. So whenever we find that the length is getting outside of our allowed window, we need to increment our start counter to shrink the window. So we check whether our start, before we do that, we need to check whether the character at our starting index has already been matched, because if it has already been matched, we need to decrement our match counter because that character is no longer part of our window and cannot be used to match any character in the reference string. So that's what we do here. We decrement the match, and then we put that back to our map, where we keep track of the frequency, the remaining instances of character we have to match, and we increment our start counter. Yeah, and that's it for this problem. Thank you for watching, and please let me know if you have any other questions about this problem, and feel free to leave it down in the comments. Thank you.